In section 1.4, we talked about the process of finding an approximation for just a single value on a solution function for a differential equation using the approximation method developed by Euler. And we filled out that entire table by hand, but what we want to do here in this project is have a spreadsheet help us with that. If we can establish a pattern in the spreadsheet within just the first couple of lines, we can very easily highlight those cells and then drag it down and have the spreadsheet fill in that pattern for the rest of the table for us. Now, for as small as this table is, it might not seem that big of a deal, but it's possible we might want to extend this table out to 100 steps, or we might want to continue using this table and change the points. We could very easily change the x and the y and get a different approximation, or change the step size and things like that. So the initial setup of the table will be very helpful, and we can do adjustments later if we wanted to use it for other things. We can also very easily change the differential equation, but just by changing the dy dx column, and use this table to do an approximation for a different function for us, differential equation for us. So what I want you to do in this project is pretty much exactly what we did on paper, except we're going to let the spreadsheet help us do some of the calculations. Now, there's only a couple of things that we're actually going to enter into this spreadsheet by hand. And one of those is going to be our initial value here. So we're told with this, you're going to be given a differential equation. So the differential equation I'm going to be working with is dy dx equals x minus 2y, and my initial point is y of 4 equals 1. So that means my first x value is 4, and my first y value is 1. We're going to have a step size of 1/10, and our goal is to find y of 5. That means find the y value that goes with an x value of 5. We don't want to calculate any of these values by hand and just type the values in. We want to use formulas within the spreadsheet and have the spreadsheet do the calculation for us. So I'm going to be referencing back to other cells in the spreadsheet and asking the spreadsheet to do the calculation. So my differential equation here is dy dx equals x minus 2y. So when I fill in this cell here for my first value for my tangent slope, I'm going to look back at the x and the y in that row, and that's the x and the y I need to use in that formula. So anytime you type a formula into an Excel or a spreadsheet cell, you got to start with equals. And I want the value in this cell to be my x value. So I clicked on where I have my x value stored, minus 2 times my y value, because that's what my differential equation says, x minus 2y. And then hit enter, and it's automatically going to calculate it for us. But if you click back on the cell, you can see up here in the function entry line, it doesn't have 2 up there. It has the formula we use to calculate it. And then the next x value is really easy. Remember, we just use the old value. So I'm not going to type in the old value. I'm going to reference the old value. And then we add our step size. And then the y is a little bit more involved. Remember, to get the new y value, we're going to do the old y value plus the slope times the step size. So I referenced the old y value, which was an E8, and then I added the slope, which was an F8, times the step size, which was 0.1. And it automatically got my new x and my new y for me. When we did this by hand, we then transferred these new x and y values down to the next line. Now do not type in 4.1 and 1.2. We're going to say this new x value is going to equal the x value from the previous line. And this new y value is going to equal the y value from the previous line. And then the slope. Again, we're going to just have to type this in for a few lines until we have 2 complete lines, I would say, full of formulas. Our first line is not full of complete formulas because we manually typed in our initial point of 4 and 1. So really n equals 1 is going to be the first full line of formulas. So again, dy dx is going to equal your x value minus 2 times your y value. And you have to make sure to type these in exactly the same every single time. If you use parentheses once, you have to use parentheses the next time. So I'm not using parentheses in my derivative at all. For the next x, it's equal to my previous x plus 0.1. For my new y, it's equal to my previous y plus derivative times 0.1. And I used parentheses here because I used parentheses last time. I need to be consistent, otherwise the spreadsheet won't necessarily be able to recognize my pattern. And this is now my new x and my new y value. I'm going to transfer them down to the next row. And don't type them in. We're going to say this new x value is equal to the x value we ended with on the last row. The new y value is equal to the y value we ended with on the last row. The derivative is x minus 2 times y. The new x is equal to the previous x plus our step size. The new y is equal to the previous y plus slope times step size. And again, I used parentheses on this one, so I'm trying to stay consistent. We now have 2 full rows. If you were to check all of these cells that I have highlighted, they all have formulas in them. They all start with equals. So hopefully I'm going to have them all highlighted here. And if you grab a hold of this little blue box in the bottom right corner, we should be able to drag this down and have it recognize the pattern in those formulas and fill in the rest of it for us, and voila, it worked. So you see, it automatically filled in the x all the way down to 4.9, the x sub n. The y's were calculated. Remember, they used the slopes. X sub n plus 1 goes all the way down to 5, and that's what we're looking for. We were asked for y of 5. So our y of 5, I'm going to go ahead and erase that question mark, is equal to 2.187792. That is what it appears to be according to this chart. And we didn't have to calculate 10 different rows of estimates here with slopes and additions and multiplications. All we had to do is type in 2 rows of formulas and then let Excel recognize the pattern and fill it in for us. And if we did have to do 100 rows, it would be simple, because all we'd have to do is have a couple row of patterns, and we could drag this down as far as we wanted to, and it would fill it all in for us. We could drag this down as far as we needed to. Now I'm going to erase that because we don't want that, but that is one of the great advantages of using Excel for things like this is, once it recognizes a pattern, and as long as we've used formulas, it can continue those formulas for us for as long as we need it to. So you are going to be assigned your own differential equation. You're going to have a different differential equation, a different starting point. Everybody's going to have a step size of 1/10, and they're going to be asked to find what the y value is at the next particular x value. And you are going to do the same thing. Just create this chart. Don't type in any numbers manually except for the very first x and the very first y. Everything else we want to use formulas and reference previous cells. That way the spreadsheet can recognize the formulas, and then we can just highlight and pull down that little box and have it fill it in for us. And we can get it a lot faster.